From example 1.10, page 39 to 40. Calculating heat transfer through conduction. A polystyrene foam icebox has a total area of 0.950 meters square and walls with an average thickness of 2.50 centimeters. The box contains ice, water, and canned beverages at 0 degrees Celsius. The inside of the box is kept cold by melting ice. How much ice melts in one day if the ice box is kept in the trunk of a car at 35 degrees Celsius? So, pinakauna baton atong i-identify ang given. This is the thermal conductivity for polystyrene foam. And then the total area. The average thickness, from centimeter we convert it to meters. Then the coldness, hotness, and especially the time. After that, mano siya nga to ang gamiton na formula. So we're going to substitute its values. For key, which is thermal conductivity, this is the value for that. And then for total area, the hotness 35 degrees minus the coldness, which is 0 degrees Celsius, all over the average thickness. Mano siya? Then we manipulate and we obtain 13.3 watts. This is the power heat transfer in watts. For finding the value of Q or heat transfer, we simply multiply the value of P times T. So, ang atong time, it is 6,400 seconds. And then the value of power heat transfer in watts, 13.3 watts. So, we obtain 1.15 times 10 to the power of 6 joules. This is the heat transfer in joule. For finding the value of mass, so, atong i-divide ang value sa Q and the LF. Ang Q, this is the heat transfer, and then the LF, which is the latent heat of fusion. Mao ning ilahang value, and then we manipulate it, and we obtain 3.44 kilograms. This is the mass. From example 1.1, page 41 to 43, two conductors end to end. A steel rod and an aluminum rod, each diameter 1 cm and length 25 cm, are welded end to end. One end of the steel rod is placed in a large tank of boiling water at 100 degrees Celsius, while the far end of the aluminum rod is placed in a large tank of water at 20 degrees Celsius. The rods are insulated so that no heat escapes from their surfaces. What is the temperature at the joint, and what is the rate of heat conduction through this composite rod? So first, atong i-identify ang given and then convert them to SI units. So this is the 0.25 meter. This is the length of each rod. The cross-sectional area of each rod. Then the thermal conductivity of aluminum, thermal conductivity of steel, temperature of hot end, temperature at the cold end. And then, para makuha na itong equation for P steel or heat conduction for steel, atong gamiton ni nga formula. So, ato lang i-substitute its values. Then, ato lang na-substitute, and then we obtain this equation for the heat conduction for steel. Then, heat conduction of aluminum, so we're going to use this formula and then substitute its values, obtain this equation. So, nakuha na nato ang duha ka equation. Ato na silang i-set equal. And then, we're going to find the value of T. So, we manipulate and then atong nakuha ang value sa T, which is 41.2 degrees Celsius. So, na natin nakuha nga 41.3 degrees Celsius from equation sa heat conduction of steel. Muna siya, ato lang i-substitute ang value sa T. So, ato na siya i-copy, then substitute the value of T. So, muna siya, ato na na-substitute ang value sa T. So, we obtain 1.47 watts. So, this is the rate of heat conduction for steel. And then, ang atong R, which is thermal resistance, is equals to length all over thermal conductivity. So now, heat conduction is equals to cross-sectional area times the change of temperature all over thermal resistance, or change of temperature is equals to heat conduction times thermal resistance all over cross-sectional area. So, ngayon nakuha mo na to ang 80 degrees Celsius. So, because this is 100 degrees Celsius plus negative 20 degrees Celsius. That's why 80 degrees Celsius. So, now, P is equals to the change of temperature, which is 80 degrees Celsius all over the thermal resistance. Is kuha na to ang common nga A atong ibutang outside that parenthesis, and then isulod ni sila duha ang R steel plus R aluminum. And then mao ni ang value sa thermal resistance for steel and then thermal resistance for aluminum. So atong pangitaon ang change of temperature sa aluminum. So, this is the formula. Atong i-substitute ang ilahang tagsa-tagsa ka value. So, we obtain 21.3 degrees Celsius. So, this is the change of temperature of aluminum. So, T equals 20 degrees Celsius plus 21.3 degrees Celsius is equals to 41.3 degrees Celsius. Diba? Tugma sila sa dire nga equation. Pag kuha gyapon na to, ang value gyapon na ni is 41.3 degrees Celsius. Tugma siya gyapon dire sa 41.3 degrees Celsius. So, kani nga equation. Then, this is the temperature at the joint. From example 112, page 45, calculating the flow of mass during convection. The average person produces heat at the rate of about 120 watts when at rest. At what rate must water evaporate from the body to get rid of all this energy? So, this is the given. And then, heat energy all over time is equals to M times latent heat of evaporation all over time is equals to 120 watts is equals to 120 joule per second. So, mass all over time is equals to 120 joule per second all over latent heat of evaporation. M all over T is equals to 120 joules per second all over 2,430 joules per grams is equals to 0.0494 grams per second is equals to 2.96 grams per minute. Is the rate of water evaporate from the body to get rid all of this energy. Example 1.13, page 49 to 50. Calculating the net heat transfer of a person. What is the rate of heat transfer by radiation of an unclothed person standing in a dark room whose ambient temperature is 22 degrees Celsius? The person has a normal skin temperature of 53 degrees Celsius and a surface area of 1.50 meters square. The emissivity of skin is 0.97 in the infrared, the part of the spectrum where the radiation takes place. So this is the given, and then the formula, and we're going to substitute its values. After that, we're going to substitute, we manipulate, and then we obtain negative 99 watts. This is the final answer.